All right, students, so welcome to the last part of this section, and we're going to do the business applications. So we now have plenty of information to use or knowledge of linear equations to relate this to business applications. This is actually part 7. Kind of got off with my numbering here. So if a cost is related as a linear equation, then the form of the equation is C equals mx plus b. And you're already familiar with y equals mx plus b. What we're doing is just replacing y with the cost, and then x is just going to be the variable, whatever you're selling or whatever you're producing. All right, so you can kind of think of it like this. B is what we call the fixed cost, and we'll talk a little bit about what a fixed cost is here in just a minute. And then M is what we call the variable cost. So that varies as you produce more and more items. Okay, so I was going to kind of use a simple example here, just sort of simplified. It's summertime, so a lot of times you'll see kids out selling lemonade. So if you were thinking about your business as simple as selling lemonade in your neighborhood, what are your fixed costs? Well, fixed costs would be something you pay for one time, and they don't depend on how many things that you're making. So it wouldn't depend on how many cups of lemonade you're selling. So I don't know, maybe you need a table to sit at, maybe you need chairs, things like that, right? Maybe you need sunscreen, okay? I don't know, just things that are kind of fixed to help you run your business. Whereas the variable cost would be like the cups. The more lemonade you sell, the more cups you need. Okay, the more lemonade you sell, the more ice you need, the more lemons you need, and so forth. Okay, so those are the things that are going to increase as you sell more and more things. So that's the way I think of that. Now, this diagram right here is just kind of showing a fixed cost is just like a line that would be horizontal. That's not going to change. The variable cost is going to be like a line sloping upward because it increases. You would expect your variable costs to increase as you produce more and more items. Then the total cost is just these two things put together. You add this, so that fixed cost becomes the y-intercept, and then you have that same slope. So that's kind of the idea. So we're going to move to the next page. We'll look at a cost analysis problem. And this is just seeing that you know how to put this together. So I'm going to write down that formula again. C equals mx plus b. All right, C is the cost, X is whatever you're producing. So in this particular problem, a small company manufactures picnic tables. The weekly fixed cost is $1,200 and the variable cost is $45. Well, okay, all you got to know on this is the structure. The fixed cost goes there. So that's your $1,200. The variable cost, which is $45 per table, goes there. All right, so the variable cost is like a slope. So your equation is going to be C equals 45x plus 1,200. All right, so that is your cost function then. It's linear. So the next thing we're going to do just a couple of simple questions on this. This says, how many picnic tables can be produced for a weekly total cost of $4,800? So at $4,800 is going to go there in the cost. How many picnic tables is X? So X is number of the picnic tables, whereas C is the cost. So you solve this equation. You would have $4,800 is equal to 45x plus 1,200. We've spent a lot of time learning how to solve equations because it's a major part of basic applications in business and other areas. So what I'm going to do is get the x by itself on a side. I'm going to do like I've been showing you, just rearrange so you have 4,800 minus 1,200 is equal to 45x. And you can use your calculator to kind of assist you with certain things. So we have 4,800, So I have 4,800. And gosh, I keep doing that. 4800, 1200. Sometimes you got to be careful how you type on this thing. So 3,600. So we end up having 3,600 equals 45x. What's next? Okay, divide by 45. And then that should give the number of picnic tables that produces that then. So now I'll just go 3,600. Dang, there it goes again. 3,600 divided by 45 gives 80. So that's going to be 80 picnic tables then. Okay, so the answer on that is going to be 80 picnic tables. All right. Now, the next thing we're going to do is we're going to do a graph. And when you start getting into pretty big numbers like we have here, well, it's kind of helpful to use technology. So I'm going to do that kind of like this. But one thing you want to know as a student is you want to know enough about graphing that you could understand how to scale your X and Y axis. So the thing on this is you have C equals 45x plus 1200. So you got to know that that's the y-intercept. So you have to understand that the first point on this graph that's significant to us is going to have a y value of 1200. So your y-axis needs to go bigger than 1200. This is the slope, which is going to tell you to go up 45 and then to the right 1. So you're going up and over. So you need to make your graph go to start at kind of 1200 for the y-intercept and then get bigger from there. All right, so what I'm going to do when I actually begin to put this together, I'm just going to draw an x and y axis. And you'd only have to do like the right part of x and just the up part of the y-axis, because that's what all that really makes any difference. And then if you're providing me a graph like that, you want to tell me what everything means. So you want to say that's x. Tell me what it is. That is the number of picnic tables. That's important. I mean, you don't just give a graph that if it's applied to an application, you got to tell me or whoever you're showing this to, what things mean. Okay, then you got to do the same thing with y. Okay, this is the y-axis, so this would be the cost, and that is in dollars. Tell me what that's in, like that. Now you're going to scale this. So the idea is, and I'm going to first of all do this on the graphing calculator, just kind of show you how that sets up. So you would want to go to y equals, and then type in 45. There's your variable key, plus 1200. Now, see, you want to set your window up. God, that thing's driving me crazy. It keeps typing an extra 0. Okay, so what we want to do is you want to get your window set up. So on this one, well, notice like if we found when the cost was 4,800, we had 80 picnic tables. So we're just going to kind of ballpark this. I'm going to go 0 to 100. I want to go all the way past 80 because I want to show you why this answer 80 is the right answer. And then we'll scale that. So we probably want to scale that by 10. So that would be a logical way to do that. So I'm going to go ahead and set that up. We'll go 10, 20, 30, 40, 50, 60, 70, 80. That's probably actually good enough if we just go up to 80 like that. Okay, and I'll just do that, I think, and then I'll change that. Doesn't really matter. It's kind of up to you how you do this anyway. But the y-axis is got to be at least go up to 1200. And when x was 80, we had 4,800. So it would be wise to go up to 5,000 would be my guess. So I'm just going to go 1,000, 2,000, and so forth. 3,000. 4,000 and then 5,000. So this is in dollars like that. Okay, so actually you're going to use your graphing calculator on this. It only takes 2 points to make a line. So the smart way to do this is get this set up. The y, we're going to go from 0 to 5 grand. Okay, and then we'll scale that by 1,000, like that, and I graph it. Okay, it's a beautiful graph. So just trace a couple of points. What you can learn to do is learn to use your technology. If we trace at 0, that gives us the point we already knew we were going to get anyway. I hope you knew that. 0, 1,200. Okay, and then let's go to 80. We already knew 80. If I trace at 80, it's going to give me 4,800. So that's actually good enough. If you get 2 points, that's good enough. And then that will give you pretty much everything you need. And that's a very accurate graph. And I want the graph to be accurate. Okay, so it goes like that. Just label that as the cost is 45x plus 1,200. Okay, so that's what your graph needs to look like. You need to not be lazy about labeling things. And since you're using technology, get accurate points. On a line, it only takes 2 points to make it accurate, and your graphing calculator is going to assist you with that. I want you to know how to do technology on that. All right, so pause if you need to. Otherwise, I'm going to move to the next problem and read this, and then we'll go to the next page and finish this up. So this is supply and demand. So this, let me read the problem first. It says at a price of $9 per bushel, the supply of soybeans is 3,600 million bushels. So I'm going to highlight that. That's an important piece of information. Okay, but it also says the demand, and I'm going to use a different color, is 4,000 bushels. All right. So we're going to kind of come up with points for supply, and we're going to come up with points for the demand. You're given enough information to find the supply and price demand equation. All right, so read on. Now it says at a price of $9.50, the supply is 4,100 million. That's why I'm highlighting in that yellow, because I'm putting together the supply equations. Then it says the demand is this. So just kind of color coding things so it's kind of visual for you so you can tell what these things are then. So the supply points are going to be this. Your points are going to have this structure. X is going to be the bushels. Whatever we have, that's the number of bushels we have. And then P is going to be the price. Now see, they want it that way. They're telling you that they want it to be in the form P equals MX plus B. So P is the Y value. Okay, that's why I know that, because we know Y equals MX plus B. Okay, so here's our points. Okay, when we have a price of $9, the supply is 3,600 million bushels. Just put 3,600. You don't have to put 3,600 million. That's a point. Now, if you read on, when the price changes to $9.50, then the supply is 4,100. So there's 2 points. Those 2 points can be used to find an equation. Okay, now we're going to do the same thing with demand. So demand is going to go like this. Okay, that's what I highlighted in blue. So it goes like this. This problem said when you had a price of $9, the demand was 4,000 million bushels. And then read on, it says when the price changed to $9.50, okay, then that changed to 3,500 million bushels. So that's the key stuff right there. So when you're reading that, you got to put together your points. You got to, don't throw your arms up in the air when you read a word problem. Think about it. What you're doing is you've been given 2 points so you can find an equation. And we learned how to do this a little earlier in the section. We just didn't really apply it to this type of example yet. So I'm going to move to the next page, and I'll show you kind of what we're going to do. So we're going to find a price supply equation. So we're going to take these 2 points. I would just write these 2 points down. Oh, cat, leave me alone. My cat is like rubbing on my feet, rubbing on the computer screen, getting in the way. Come over here and learn something, cat. I have a cat named Bigfoot. All right, so there's our 2 points. That's because she has big feet. All right, now the slope, what we're going to do, we're going to go ahead and find the slope. So we do that by the slope formula. You subtract the y's. So we got, and it doesn't matter which order. So I'm going to choose to do it that way. And then you need to be consistent in the order. So now subtract the x's. 4,100 minus 3,600 like that. Kind of check carefully on the calculator. So the numerator is 0.50 and then the denominator is 500. Okay, so now what I'm going to do is I'm going to just use the calculator to crunch this thing out then. So again, 4,100. Oh, quit doing that. Okay, 4,100 minus 3,600, just double checking, that's 500. Okay, 0.50 divided by 500 will give that slope. Okay, and let's just leave that in a decimal form and write that as 0.001. So that's your slope. Okay, now remember we learned the formula y minus y1 equals m times x minus x1. What we're going to do is we're going to change this slightly. We're just going to say C minus, P. Y is really a price, so we're going to write this as P minus P1 equals M times X minus X1. So it doesn't matter which point you plug in. Just pick a point. I'm going to pick this point and plug in. So what's going to happen is the 3,600 will go there, and then the price, $9, will go there. We'll plug in and we'll solve for P. So we're going to get P minus 9 equals M times X minus, not M, come on. I know what M is. So remember, we just got M as 0.001. So I'll have P minus 9 equals 0.001 times X minus 3,600. Okay. So then I go through and do distributive property. I'll be P minus 9, 0.001x minus, and then take your calculator if you need to. If you multiply by 0.001, what that does is moves the decimal back to the left. God, that's driving me crazy. Okay, 3,600. What it does is it moves it back 3 decimals, so it'll be 3.6. Kind of nice to know basic things like that. Oh, come on, type right. Shoot. There we go. 3.6. Okay, so that's going to be 3.6. And then all we need to do is just add 9 to both sides. Just move that to both sides. So you would get P equals 0.001x. And then you can do this on your calculator. So 3.6. Oh, come on. And then plus 9. Shoot. I have to touch my screen or use my mouse, and sometimes this thing doesn't work very good. So 3.6 and then plus 9. Hold on, I got a negative. So negative 3.6. Come on, teacher. There we go. Finally. Okay, so I got plus 5.4. All right, so that's what we get as our answer then. So I'm going to write this over here. The price supply equation is 0.001x plus 5.4, like that. All right, now I'm going to let you do a little work here. Instead of just watching me, I'm just going to have you kind of repeat what I did. We're going to do the demand equation. So go ahead and write down these 2 points that we had on the previous page right here. So we had 4,000, and then you can just do 9. And then we had 3,500, and then we had 9.5. So don't wait for me. Crunch it out, do it, and make sure you're on the right track. So go ahead and pause the video, and then when you're ready to check. Okay, so let's check your work and see if you got this. The answer is P equals negative 0.001x plus 13. I'm going to show you how I checked my answer on this, by the way. I used this point when I plugged this in. So I decided just to do a quick check to make sure I didn't make a mistake. So I used this point. So if I plug the 3,500 in for X and the 9.5 in and see if that's the price. So I notice I did negative 0.001 times 3,500 plus 13. I got 9.5. So that pretty well proves that I got the right answer to the problem. Okay, so if you had trouble doing this, just look over my work and see if you can figure out where you went wrong. The first thing is the slope is negative. So I just did subtract the y's. I did this order. Subtract the x's in the same order. You have to be consistent about the order that you subtract y and x on the slope formula. If you did 9 minus 9.5, then you would do 4,000 minus 3,500, and you would get negative 0.001. Okay, then I chose this point. It doesn't matter which point you plug in, you're going to get the same answer anyway. So I use this point slope formula, plug in the 4,000 for x, the 9 for P1, and then the slope, and then solve the equation. Okay, just check your arithmetic. All right, so now next thing I'm going to do is show you algebraically how to find the equilibrium point. Then we're going to graph this, and I'll show you how you can also do this equilibrium point graphically. So what this means is where these two lines intersect. Okay, we'll see that in just a minute on the calculator. So you can think of it as where the prices end up being the same. All right, so what we do is we just set these equal to each other. So take the right side of this equation, set that equal to the right side of this equation, and then this, see what we're doing is we're figuring out where the prices are the same. We're figuring out what production level, the number of bushels, make the prices to be the same. So then what I'll do is I'll move this over, move the x over there, move the y over there, just kind of rearrange. So we would have 0.001x plus 0.001x equals 13 minus 5.4. Those are like terms. That'll add to 0.002x. If you want to take a calculator and go 13 minus 5.4, I'll give 7.6. And then you can finish up by doing the division. Okay, and that will end up giving us x equals, so I'll take my calculator and do 7.6 divided by 0.002. There it goes again. Okay, I think I got it right there. All right, so that's 3,800. All right, so what we'd end up having is x is equal to 3,800 is where that happens. All right, now what I need to do is I need to find that price. So if I find the price, it doesn't matter which of these two equations that we use. So I'm just going to take this equation I highlighted in blue. So I'll have P equals 0.001 times 3,800 plus 5.4. So I'm just plugging in that 3,800. Now I'll take my calculator times 3,800. Crap. 3,800 and then plus 5.4. That'll give me what we call the equilibrium price. So that equilibrium price is $9.20. So the answer we would get is 3,800 million bushels at a price of $9.20 is the equilibrium point on that. That's how you would do that algebraically. I'm going to show you in a minute how you can do this graphically. I think you want to know how to do that both ways. Technology as a computer programmer is figured out how to make the computer do what we just did anyway. All right, so that's what's behind the scenes. All right, so let's go ahead and we'll do the graphing part of this. So let's write down these two things and kind of keep track of which is which. Okay, so the supply equation was P equals 0.001x plus 5.4. That has a positive slope, so it's going to slope upwards. And then the demand equation was P equals negative 0.001x plus 13. That has a negative slope, so it's going to slope downwards. So we're going to have two lines that are going to intersect. So when we put this together, as we do this, we're going to do this on our calculator. So you want to go to y equals and then put in the supply equation. So that's 0.001x plus 5.4. That 5.4 is the y-intercept, so that will help you to understand how to make that y-axis. Okay, and we'll kind of talk about what we've done so far. It'll help us figure out the axis. And then put in the demand equation, which is negative 0.001 times x plus 13. That 13 is the y-intercept. That'll tell you your y-axis needs to be at least go up to 13. Okay, so that's what happens on that. Now, I'm going to go ahead and we'll go ahead and put together a graph. So you want to go ahead and just draw a positive x-axis, draw a positive y-axis. All right, and label what we get. So x is basically, this is million bushels. Okay, and then P is the price. That's your P axis, so that's the price. And that's a price in dollars. Okay, so the way I look at this is, all right, go back and look at that equilibrium price. Okay, so your number of bushels is going to have to go out, bigger than 3,800. Okay, because we want to get a good picture of where these two lines intersect. So I'm going to start by doing this. On the window, I'm going to go, let's just go 0 to 6,000. Okay, like that, a good way to scale that would be by 1,000. Okay, now your prices, now you got to look at these y-intercepts. See, this y-intercept's 13. This y-intercept is 5.4. So you probably need to make your y-axis go a little bigger than 13. Okay, that's what I'm suggesting. So let's just go 0 to 15, maybe scale that by 5. Okay, so let's try that approach, and I'll put the window up here. I'm going to go ahead and graph it, and that's a pretty good looking graph, see. Okay, so I'm going to slide this over. I'm going to do two things. I'm going to put the window over here so you can type this into your calculator. Okay, so we have this, and we have this. So you want to get that information put in, and then we're going to use our calculator to get a good graph drawn on here then. Okay. All right, so we're just going to repeat this graph. So what we have is we're going to make the x-axis go to 6,000. So 1, 2, 3, 4, 5, 6,000. And if you label the last one, that's okay. Or just at least label the first and last. Okay, the y-intercept went up to 15. So we'll go 5, 10, 15. And these things are in dollars like this. Now, again, what we'll do on this is I'm going to get my calculator out and I'll show you kind of how I do this. If I want to get a really good, accurate graph, I'm going to use the trace feature of my calculator. Now, watch this closely. If I type trace, right now I'm on the blue line. Okay, so I'm going to get 2 points. We got lines. It only takes 2 points to make a line. Let's trace at 0. Okay, and that'll give us 5.4. Well, we knew that anyway. That was the y-intercept. So what I'm going to do on this one is just kind of estimate 5.4. I'm going to trace at 6,000, which is the biggest value that I have on my x-axis. Oh, come on. Okay. Shoot. Hang it. This thing drives me crazy sometimes. So let me fix this. Okay, there we go. I don't know what I did. Okay, so anyway, what I'm going to do is trace. See, I'm on the blue line. So trace at 6,000. All right. And that gives me a point of 11.4, see. So what that means is I'm going to, on my graph, I'm going to go over to 6,000 and then just estimate up about 11.4. Now that doesn't have to be perfect. And then we can connect the dots. I'm going to try to color code this. So I'll do this. Just connect the dots, and then I'm going to label that. And that line will go on continuously. So that is the supply line. That goes like that. Okay. Now on the calculator, I'm going to repeat, but I'm going to get 2 points on this red line. Now watch carefully how I do this. If I type the trace button, right now it's only tracing the blue line. If I want the red, I got to do this. I got to toggle with my up and down. See how I'm doing that? Okay, I want it to be red. So now it's going to be tracing the red. So I'm going to type 0, which will be the y-intercept of 13. See, we knew that anyway. So that's about 13. Now trace at 6,000. Okay, and that'll give me 7. Okay, so you're kind of down. Again, just ballpark it like that and get that point put together, and then we'll draw that. Then I'll show you next how to find that equilibrium point with your graphing calculator. All right, so that's what we have. Now what we get here is this intersection point. That's going to be the equilibrium point. So here's what you can do on your graphing calculator. Watch this carefully and try this. All right, so we got your graph. Okay, so what I do is I press second, trace, option 5, intersect. Write that down if you need to. I'll write this down over here. So it's second, trace, option 5, intersect, then press enter. Okay, in that order again. I'll do it one more time. So it's second, trace, option 5. You can just type 5 or go down to it, press enter. Okay, first curve. Now you want to locate your cursor. I can see the cursor blinking. Just move it in. It doesn't really matter on this problem, but move it in pretty close to that intersection point. That's good enough. First curve, type enter. A new cursor will come to the second curve. Press enter again. It's going to say guess. Press enter again. There's your equilibrium point, and that's what we got. So notice on here that that was 3,800, 9.2. That's what we got on the problem. Okay, so you might want to make sure you know how to do that again. It's second, trace, option 5. First curve, press enter. Second curve, a new cursor comes up, press enter. Says guess, press enter again. And that gives the equilibrium point. Now see, that verifies what that answer is then. So what that means is this would be a point where the supply and demand are equal. Typically supply increases as you produce more things. The price increases when the supply gets bigger. And I kind of think of it this way. If the supply is big, people are, what's happening is the demand's going down. So what happens as the demand goes down, the price typically will change, right? So you've got a supply curve going up, a demand curve going down. That equilibrium price would be $9.20. So that's where the supply and demand are equal to each other. Okay, so that's the idea. That'll give you kind of a good business application to get you started with. Okay, all right, so that's all I'll do on this section then. Good luck and happy homeworking.